Well, thanks, Vivian. Good morning, everyone. Good morning also to those at Armidale and online. This is, as Vivian said, the session on automation. We'll do a bit of a deep dive into various aspects of automation for the farm. We'll look at the technology itself. We'll look at the benefits that it can deliver, productivity, economic benefits. We'll look at issues like sustainability. We'll look at the barriers also that farmers might experience in implementing it. And we'll also look at the investment side, so the capital providers, the capital receivers, and how that marries up. So to set the scene, our first speaker will set the major presentation will be Professor Salah Sukkarieh, who heads the Australian Centre for Field Robotics at the University of Sydney. And after Salah, we'll move to the panel session, where we've got 4 panellists. They're all from commercial enterprises, and they cover a whole spectrum of automation in agriculture. So I think you've got a perspective from a number of different perspectives from their side. So let's kick off with Salah with his presentation.
Thanks, Chris. Okay. Thank you, everyone, and welcome. And it's great to be here. And I'm going to stick to my lane and focus on the R&D side and parts of the future of autonomy, because we have a great panel after this talk, which we can kind of focus on the more detailed aspects around commercial investment and long-term. The work that I'm going to be looking at is understanding how field robotics, so robotics have to work outdoors 24 hours, 7 days a week, coming together now with a lot more around predictive analytics and the kind of solutions that we're starting to see in that space and what impact that has on the world of automation on farm. Next slide, please. I've used this card a few times. I like it because this is back in 1900. The people of Paris were asked, what does the year 2000 look like? And they had to come along with a whole bunch of different ideas. And this is one of the postcards that came out of that process. And as you can imagine here, it's the thought process that you can see here is how the Parisians look outside of the farm, so looking at technology landscape and what's changing there and kind of bringing it into the farm, and that's what we're seeing around in AgTech, and we've been seeing it for a long time. But, the kind of classic aspects there, electricity is starting to form, how, kind of using it on farm, a farmer that's smiling and happy, which is something we think about when it comes to AgTech and what that solution might look like. But in general, a single person being able to manage a farm and doing all the different bits and pieces that you see. If you fast forward not 100 years, but 125 years. So the next slide, please. The AgTech landscape is quite complex. There are many different elements now. They can be categorized into various areas, but you can't really put a particular company now in a particular box anymore. You're starting to see that morph across into different categories around the way. And generally what we're seeing is this explosion of this technology on farm. Again, a lot of this is technology that's been developed off farm, but now being applied and instantiated in different forms on farm. So we're seeing a lot more of that. Some of these companies, I think even last week, we heard one of the darlings of the US, FarmWise, is now closing. That's been around for almost 10 years now and expected to be growing. So what I'm getting at here is that the technology comes in and comes out, right? Kind of seeing this process unfolding. Next slide, please. Where that's really coming from, is this concept of, kind of AgTech 1, 2, 3, what happens on farm. It's following the industry kind of cycle. So industry 1.0, industry 2.0, et cetera, et cetera. Where we're up to now is this 4.0, which started just over 10 years ago, but it's really kind of morphing into fruition at the moment now. And really what that is about IoT, so Internet of Things, and its application that's been out in industry, but again now applying it onto the farm context. And so in that previous slide where I showed you that landscape, really what we're talking about now is sensors, chips, communications, AI on mobile platforms, whether they're drones or ground robots or even just sensors being plugged into the ground. And so that's been a lot of growth in that space. And my experience so far, kind of, working almost 30 years in this R&D space, is it takes about 5 to 10 years for this technology to kind of grow out of the lab into the commercial space. But then it takes another 5 or 10 years for that commercial space to really find the value proposition. Generally, that technology is morphed in some way. It's pivoted so many times. It's changed in some way for that. So you're kind of seeing this 2 decades long activity before something goes out onto farm. But next, please. But what we're also seeing now is this stage moving into this Ag 5.0, and what that's really about is how we're bringing the human back into that loop process. This follows the Industry 5.0, really looking at sustainability and aspects around that on farm and how technology can be used to support that. But to do that properly, it's bringing the farmer back into that loop, into that design process, into that implementation process as well, in order to make that work. And so it's quite a different field. And what we're seeing now is this, it's not just the hardware, whether that's computing and sensing and actuators, or the software, which is a predictive analytics, but also this mechanism by which there's this co-intelligence process that's happening with the stewards of the land, or even the scientists who are using the technology on farm. Next slide, please. So I'm just going to kind of walk through that in a little bit more detail. So we're talking about physical assets, so whatever's there on the farm. Next, please. And that also includes adding your technology on that farm, whether that's field robotics or IoT systems. And in the past, in Ag 4.0, what we're seeing is that links into the digital assets, right? So what you're getting now is this digital asset space, whether they're maps or data that comes through in any form. Next, please. But what's happening over the last 5 years, especially with the use of AI techniques, is now we're starting to get into this predictive analytics world. So what does it mean about taking this data analytics and then starting to use that to predict forward what the farm might look like? Now, whether that's the health of a crop or the potential for certain pests or diseases to infect it, or where I'm going to move my assets next or the animals next, etc. So we're starting to see that a lot more over the last 5 years. But to get into this Ag 5.0, so next, please, it's the synergy between that digital world and that physical world. It's not just a separation of the digital asset and the predictive analytics from the physical part, but it's that synergistic process that happens between them. And what I mean by that is how the predictive analytics now will be controlling the physical assets in whatever form, and likewise how the physical assets will be able to collect data or use data in some way that improves on that predictive analytics. So that's one part of the Ag 5.0. The other part, so next please, is then the process by which the end user engages with that system. So it's not just I'm now looking at a map, what do I do? But is there this process where you start to, both in design and in fusion of knowledge and information and action, do you get this kind of seamless approach and interaction between, in this case here, the grower or the scientist and what's happening on farm? So we're seeing these two green cyclic things happen as part of this Ag 5.0 element in the labs anyway. So again, going back to it, this is all at the beginning of these stages now and moving on. So I'm going to go through some examples. So next slide, please. So we're going to look at row crops and some of the work there. So next slide. So this is work back in 2018 and 2017. So what you have here is just an autonomous platform, up and down rows, sensors on board, machine learning techniques in real time, detecting individual plants and being able to assess and understand and quantify individual plants. We looked at before about green on green aspects. This is our yield estimation and being able to do yield estimation. We discussed before about green on green, but this is a classic cycle. This was 10 years ago, being able to do green on green and doing some mechanical weeding, but it takes this long before you kind of get that technology to a commercial reality as what we look at now. So this is the ability to kind of detect a weed from the plant, not use any chemicals, remove it. But if you're going to use chemicals, can you do things like precision spraying, which is what you'll see next. In this case here, just targeting individual plants, knowing how much to squirt, at what angle to squirt, so it's like a flexible nozzle there to kind of do that. And the other part of this particular project was also looking at soil, being able to quantify and understand what's going on in the soil. In this case here, water, and looking at water moisture below the soil. I'm building up a map of that. So what you see there in that piece of work is a number of pieces of technologies coming together in one form. But if you take a step back and kind of look at it from a larger perspective, the kind of focus of that project was what does it mean to have almost like a digital agronomist? So something that's constantly collecting data on farm continuously across many different spectral modalities, and also being able to do these tasks on farm. And if you could do that, then how does that change or modify the work forward? Next slide, please. So one of the key pieces of activity that we looked at was if you were on farm continuously, which is what you're doing, you're weeding continuously, so you're collecting all this data continuously. If you're on farm, then after a certain production cycle, you start to learn how plants behave along certain parts or sectors of the farm. So you can go down now to the individual plant and you can start to do things such as predict and estimate what its future yield growth down to the individual plant level. And that gives you some piece of information about that, but also you can start to look at the susceptibility of that plant to pests and diseases as well as part of that. And we've done lots of experimentation work where we've looked at focused plots of land, add different levels of fertilizer, add different levels of water, and from that being able to use that to and the reason why you do that is you want to train the machine learning algorithms or adjust the machine learning algorithms to kind of look at different responses. And then you can start to get these predictive results quite accurately as you're going through. And that was then incorporated into various models. So next slide, please. So this was the next manifestation of the projects. This is with Reichswan, who are interested in breeding. So this is many different plants along a particular road, trying to understand the different characteristics of those plants. So you can then come along and start to build up this real-time dashboard where you start to see things like, for example, okay, you can individually count plants, that's great. You can start to look at the crop health. Those red dots that you see there is where the system has detected certain plants are not behaving on average the same as all the other plants are behaving. So you're going down to that individual level. You can kind of look historically, the change and the trends in that space as well. So you start to get this very precise characteristics of what's happening on farm. And then down below there, you can kind of see that middle one is probably the most important one out of that one, which is the crop growth over time split by variety. And what that is both the measurement, but also the predictive analytics, kind of predicting what the growth of those plants would look like, and being able to kind of relate between those different plants. So that's just showing you how, again, field robotics, predictive analytics are all coming together in that space. Next slide, please. And next, so I'm going to talk about grazing livestock now, which is a bit more of a complex scenario. So next. Thank you. We've done a lot of work on how to use robotics in this quite complex environment. You're not only talking about pasture now, but we're also interested in soil. This is about regenerative ag, and you're also interested in the animals as well. So there's this very tight corridors for the graziers. You'll know this about how all that comes together. And the idea is, how can you turn what is a very large-scale operation, very complex, into a precision ag kind of environment in some form? Next, please. So our previous work was all about the animals, and what we're looking at now is soil. And one of the challenges that we said is, can we measure certain macronutrients, in particular NPK, pH, and water in real time? So that's really what the focus is on now. So how do we move away from just taking a soil sample, sending it to the lab, waiting 2 to 3 weeks, and then getting results back? So this is on the bottom of the robot. It's basically a lab on wheels. It's taking a soil sample. It kind of dumps the soil into that little turret, which moves around. You're mixing it with whatever chemicals there are. There's going to be some mixing there. And then we go through a centrifuge process, and then we shine a laser, get the spectrometer result, and from that you can start to measure things such as, at the moment now, nitrogen and potassium, soon hopefully phosphorus, but also pH measurements as well. So if you can in real time start to measure what's happening below the soil, you've got some sensors on the top which are also measuring the pasture. And the question is now, if you can do that, then where does the robot, one of the kind of research questions are, you've got this large, 1,000 hectares of land or whatever it might be, even more than that, where does the robot go next in order to be able to accurately measure what's going on below the soil and on the pasture? And to do that properly, you need predictive analytics as well. So next slide, please. So here we've got 2 cases here of the robot moving, in one case looking at measuring pH and NPK, the other one measuring pasture. And what the robot's doing in both cases here is it's not being told where to go. It's taking measurements below the soil and on the pasture. It uses specific machine learning and predictive statistical analysis techniques to predict how that composition would change depending on the terrain and the water that it's measuring, whether it rained yesterday, etc. And then dictating it should go to another location, and then in that particular location it's where it's the greatest uncertainty. And based on that, it will take another measurement to maximise the amount of information about what's going on. So you're trying to maximise how much information with the smallest number of samples, and do that in real time as you're going through. So that's just kind of collecting that information below the ground. Next slide, please. Another one is on water sensing over large terrain, so using the same concept. So here, instead of kind of putting a sensor in the ground, this is using radio frequency techniques over large, being able to transmit a radio frequency signal and picking it up at the other end. And what happens is, depending on the soil moisture in the ground, it actually attenuates that radio signal. So you can actually then infer how much moisture there is in the soil, and you can do that over kilometres without putting sensors on the ground. So you're now measuring water, macronutrients and pasture. So you're starting to get this kind of collective piece of information about what's going on below the ground and above the ground. Next slide. Thanks. And so what we want to do now is be able to kind of close that loop in that process back to the animal again. So we're talking about regenerative ag here, and so closing that loop back into where the animals will go to next or forage next. So we're working with some scientists in ecology and nutrition science. They've done a lot of work around animal foraging behaviours in Africa, mammals over there. And so basically social animals that move as herds will then kind of focus on certain aspects around protein and carb in the environment. And depending on their social context, they'll either eat in certain locations, not eat in certain locations, stay away from each other in certain ways. What hasn't been done is the application of that into the cattle industry. So we've had this project over the last 3 years about how we can use their models, their foraging models on cattle. So now we're measuring below the ground, water, macronutrients, pasture, and understanding where we think animals will move based on what we think is the protein-carb mixture of the pasture in the environment. So on the next slide, this is some of the latest work now, which is trying to look at if you can, in the top left there, this is just the classification of an environment between protein and carb in that pasture. And when you apply this model, you kind of get a behaviour response about how the animals will move based on that aspect. And what you really want to be able to do is say, well, they're going to move to a certain location because they have certain social properties, but also what they feel or sense is going on in the pasture out there in terms of protein and carb. And really what you want to be able to do is move them to the right location, either to not, so they don't overgraze particular areas, or to go to particular areas where you think that the protein carb mix might be better for their own health in whatever form. So this is one of our first projects where we thought we could kind of move the cows when we learnt that wasn't going to work in a classic, send out the dog style. But at this particular case, we found the Pied Piper approach worked well. You just leave the robot out there for long enough, the animals get used to it, and then you kind of move them around. So what does that mean about no fences? Okay, that's one thing. But the other thing that we're looking at is what does it mean about moving them to certain parts of the land where it might be better? So next slide, please. So that's kind of tying that loop. So what all the projects I showed you, that's both in the horticulture as well as in the grazing livestock, is showing both predictive analytics running in real time and closing the loop on what the robot's doing out in the field. And that is that kind of next phase that we're seeing now. What we kind of see now, and mostly in the commercial sense, which came out of the R&D labs a few years ago, is just okay. There's assets on the ground, collecting data, they're turning into digital assets. Separately, there's predictive analytics, which is informing the farmer. And what we're seeing now is this closer synergy in that. So the next bit, next slide, thanks, is now what does it mean in terms of this space? And this is where we're kind of seeing a lot more of the computer science folding in with the ag engineering elements. Next, please. You're kind of hearing a lot about the aspects of large language models and what they mean. And so, we're all mucking around with ChatGPT in some form, or Claude or Falcon 40B or whatever. So a lot of the companies now, what they're doing is they're taking their own documentation, their own internal documentation about how they might operate on farm. They put it into these large language models, and then you can start to query these models quite easily. And that's now relatively easy. It's language talking to language, so your language talking to text, and you're kind of retrieving information from that text. But what we're seeing over the last year in predominantly, so next please, is this aspect called multimodal large language model. So it's the ability now to query more than just text. You can query pictures, you can query videos, you can query multimodal data in various forms, and it's becoming quite powerful. A recent paper, so this is just 2 papers that are coming out, which is looking at multimodal large language models in agriculture in various forms. A recent paper was, and we talked about satellite data and remote sensing before in one of the talks, it was called Pixel to Prose, and it was the ability to kind of use large language models to query collection of satellite data of different spectral responses, and being able to ask questions in a typical user silo, what's happening with my crop? And what it does is it then ingests and starts to read in the different spectral data and being able to kind of analyse that information quite easily. So I think that's going to really kind of change a little bit in terms of that game, in terms of how an end user now will start to interact with this technology, whether it's robotics or IoT sensors, as well as the predictive analytics. And I think that's just going to make it easier, just like how we might be using it to kind of help us with an email or the next document or whatever it might be. The ability to kind of have growers or scientists be able to use this high-end technology in some form in a much more seamless manner is going to be important. Next slide. So just as an example, if I took one of the veggie crop ones, so next slide, and we applied it into a kind of large language model or multimodal set, I'm not going to read through this, but show me the growth divergence due to light stress. That's just a simple query. Okay, not going to ask any more than that, not going to do any more. But with the documentation and the data that feeds in behind it, it can come along and start to analyse what the latest data was collected on farm. So this is me just interfacing with the robotics and tech, and then using that as a feedback return to come along and say, this is what's happening on farm. Next slide. Okay, and so predict the yield if fertiliser is added and compare it to row D under the current conditions. So again, querying it just with normal language-based text, but what it's doing now is it's searching into the data that's been collected across different multimodal frequencies. There's some information there about agronomic principles for how lettuce might grow, and you're using that information as going. So you've got this query now process that's happening in that space. Now, whether there was another paper that came out, which was how large language models are causing inaccuracies on farm, right? So that we're not saying that everything's correct here, right? Because the predictive capabilities here are still out there. Things still need to be tested, but it's giving you that sight into what that user interface may look like. Next slide. And an example I wanted to show here was really around the cattle. So this is showing you two types of user interfaces. One is, we're hearing a lot about digital twins, and digital twins in robotics has been around for 20 years. It's just this cyber physical world that we've always been working in. But how do you take the user interface into kind of giving that information about what, if you sent the robot to a certain location, what's the predicted capability? That top left-hand picture is showing you a much more complex scenario there around that cyber physical world. In the next slide. So the query here, read it. Okay, so 10 a.m. I'm ready to move the animals to another paddock, depending on what you tell me. So depending on what the system is. As a farmer, I'm saying I felt that the animals weren't happy yesterday, and so the kind of system goes through the data, analyzes the data as it's going through. Again, remember it's multispectral, looking at different free and kind of giving that assessment and that free. And it's also coming along and saying, what does it want to do? There's different options. I think the right way for this to work is not so much dictate what the system should do, but to give options to the end user, because obviously the end user has many other aspects that are in there. But it's measuring a whole bunch of different processes and saying what it's going to do now. Next slide. Okay, so and it's before the system moves, we're asking now. Remember those soil sample sensors that I mentioned before? What's the NPK and water analysis in that paddock? And it goes through that, and then you can tell it, okay, start to move the animals, and it then kind of dictates the system and tells the bot to then move those animals across. So next slide. So this is my final slide. So I just wanted to kind of just touch on again what we're looking at. On the bottom right here, over the last 10 years, has been this kind of physical asset of field robotics, IoT, building up digital assets. Last 5 years, we're seeing a lot of stuff around predictive analytics. What we're seeing now is this mergence of the two together. So we're seeing this synergy between the predictive analytics and the physical system, and then working together collaboratively. And the final bit that was, the bit that, at least in this talk, the kind of stuff that we're talking about now is about how we're using different models, AI models, to allow that interface mechanism between the user and the system. And that's really touching on that final column, that Ag 5.0. So if we're trying to look at sustainability aspects, as we talked about before, how does that merge into that system? So thank you.
Can I ask the panel to come up now? Okay, thanks, Salah. Are we on the mic? Thanks, Salah, and for that seed-setting presentation, which covered a fairly deep dive into a number of aspects of it. We've got here on the panel today 4 representatives of companies who are actually in that space doing some work in various different dimensions of it. I'll ask each of them to introduce themselves, just a couple of minutes, a bit of background to what you do and your company to set the scene, and we'll get the diversity, I think, coming through there. And then we'll launch into a number of panel discussion topics. I'll lead that discussion here, but also just for the audience here, Armadale online, activate the Slido, the questions can come through, and we'll have probably 15, 20 minutes for questions at the end of the session. Okay, so our first panellist is Sarah Nolle from Tenacious Ventures. Sarah.
Yeah, hi, thanks all. So I'm the CEO of the Tenacious Ventures Group. Our mission is to unlock impact at scale in agri-food systems. We do that through our investment side. We have just over 50 million in funds under management and growing, investing through currently a venture capital model in agri-food tech all along the value chain, and then an advisory business doing strategic work with agribusinesses, industry, research, government on overcoming barriers to adoption and commercialization. So that's me, and a lot of our focus and several of our investments would touch on autonomy and robotics, but kind of digital revolution of agriculture more broadly.
Okay, next panellist is Jesse Reader from Hort Innovation.
Thanks very much. Jesse Reader, Head of Investment, Growth and Commercial at Hort Innovation. We are a grower-owned research and development corporation representing some 37, 38 industries with respect to levy-paying industries. So my role specifically within the business is to drive our non-levy side of the business, so our external co-investment part of the business, where we invest alongside government, universities, corporates, farms to accelerate more transformational R&D. We invest into more under-researched and underdeveloped areas where the coming together of multi-industries sees us hopefully deliver more benefit and impact where an individual industry couldn't do so. We've got a range of investment pathways that allow us to do that. One is our strategic partnerships pathway, which is the mainstay of the program, which sees us do a lot specifically with our levy-paying industries on bigger, bolder initiatives, as I mentioned. We've recently just launched the Australian Grown Innovation Program, which is a pre-accelerator of sorts, very much geared at targeting those very, very early stage ideas. So every grower you meet has got an itch they wish they could scratch, or an idea that they think is the next revolution. We're giving them a platform to learn how to pressure test and validate those ideas. And back in late November, we launched the Hort Innovation Venture Capital Fund to invest into early stage high growth businesses. Thank you.
Thanks, Jesse. Jay Gelotta from Goanna Ag.
Hi, I think I have a couple of slides. Thank you. So I'm CEO of Goanna Ag, a small AgTech company hoping to get money from these guys. And I've been working there for 3 years. Prior to that, I worked in AgTech for 13 years in Case, New Holland, the tractor manufacturer. So farmers have been shouting at me for 15 years to make these things work. Goanna Ag is an impressive Australian company. Started in a backyard in Queensland about 20 years ago. 2 guys saying, we've got to do better with our limited water. Why are we wasting it? And we can get more out of it and help our community. So it really turned into a real company about 7 years ago with investment, and we've now got a significant footprint in Australia and in the US. We provide a variety of on-farm telemetry solutions. Our most popular product is called GoField. The tagline is more crop per drop, and that basically explains the whole concept. So optimize your water productivity, and that's obviously water is a huge limiting factor in Australia. We are the experts of managing water deficits and getting through droughts, and now the rest of the world is also starting to agree that they have a water problem and they can learn a lot from Australia. We are strong in cotton, corn, soybeans. A lot of our corn growers in the United States are heavy users of our products, and they've changed the slogan from more crop to more chop per drop. So we are also trialing new crops all the time, horticulture and viticulture at the moment. So the solution consists of devices, software, and a real person. So an agronomist calling on the farmer every few weeks discussing their irrigation practices and how to improve and ensure effective adoption of the solution. And the full package is sold as one seasonal price, so hardware, software, and a person. Sue asked earlier about seeing things through the lens of the user, and we take that very seriously. We had a lot of loyal, long-time customers that participate in our focus groups, and they debate and argue and protest and vote on the future roadmap. But as we expand, I would even consider our user is not just the person who operates or pays for it, but our user is also the soil, the land, the water, and we need to listen to those important silent users. And that's where we come into data. So we've been collecting data for a long time, and we need to listen to it. And fortunately, with the evolution in the last few years of AI and machine learning, all this data that my CFO keeps complaining about the cost of storing it and processing it is now suddenly the hero. So we can go to the next slide. So by constantly analyzing, we can make predictions. Sue asked about practical examples. So 3 that I've shown here today are irrigation. We regularly predict the optimal irrigation timing based on what's biologically optimal. So maximizing yield and maximizing your water. If you irrigate too early, you've wasted water. If you irrigate too late, you've impacted yield, and there is a perfect spot in the middle. For planting, we've developed extensive models with the help of CSD. CSD is the primary cotton seed supplier to all of Australia. They have a huge problem of people blaming them that their seed doesn't work. Whenever the crop fails, it's because of the seed. So we did a study and we found that almost 15 to 20% of growers, even in Australia's sophisticated cotton industry, were planting too early. That leads to either a struggling crop or, in the worst case, an expensive replanting. And with a fairly simple model, in a few months we were able to accurately predict ideal timing of planting, and this was used by about 6,000 growers last season. For spraying, earlier you spoke a lot about chemicals. A big challenge with spraying is, when is it safe to spray? Spray drift is still a huge problem in Australia and overseas. And even if it is safe, when is it effective to spray? When is that plant happy to receive those droplets and process them correctly and efficiently?
Jay, we'll just pause there. We'll come back to some of these issues in the discussion. Okay. So our last panellist just to introduce is Marcus Agnew from Beanstalk Ag.
Thank you very much for having me. My name is Marcus Agnew. I'm from Beanstalk AgTech, which is a leading AgTech ventures and advisory firm. We focus on unleashing the power of technology to help build profitable, sustainable and resilient agri-food systems. The part of the business that I'm in is I head up our venture studio, which is funded with funding from the Australian Government's Future Drought Fund. We launched it last year, and the whole purpose of the Venture Studio is to work with really early stage entrepreneurs and innovators to help them commercialise technology that has a drought resilience application across all sort of industry verticals, or agri-verticals rather, in Australia. Prior to joining Beanstalk, I spent about 6 years across a variety of agri-input companies globally, so the UPL Group and Arista Life Science. And I started my career doing some agri consulting with McKinsey & Company in Australia.
Okay, thanks, Marcus. Well, let's get into some discussion, building on what Salah's done this morning. The evolution of AgTech, look at it from the farmer's perspective. What are the current attitudes towards implementing AgTech? Small farms, large farms. I know a couple of you, Sarah and Jay, you've got experience in the US. Is the adoption of AgTech in the US, are they hungrier for it there than here? Is there a different attitude to it? Is it the same? So anyone, lead off. Sarah.
Sure. So I would say the way that investors talk about innovation in agriculture is called AgTech, and they like putting tech after things. And we've got, med tech and hard tech and deep tech and all these kinds of things. I don't meet a lot of farmers who think about it in those terms. Often it's more about, what part of the business, how is it adding value? Is it a physical product or a digital product? So I think there's really no one size fits all tech, and there's no one size fits all farmer, which makes answering that question really complex. We have a podcast, and I often ask farmer guests, what's the most valuable piece of technology that you've ever adopted? And I often get things like, well, my tractor or my two-way radio or, those kinds of things. So if that gives you any sense of, when farmers are thinking about technology. At the same time, many, multi-six-figure, if not more, investments into novel biotechnology, in seeds and inputs, into trialing and testing infrastructure, into increasingly autonomy. So I think that answer actually undersells, I think, how innovative many farmers are and how they're thinking about technologies. I think lots of different answers at scales and across geographies. The standard sort of adoption curve, I do think, applies. You have growers like anyone who are quite on the cutting edge, willing to be on the bleeding edge, willing to take things on that they know probably won't work, and others who want to see all of their neighbors adopt it, fail, get the next version, fail, get the next version before they're going to try it, and everyone in between. And I think, interestingly, that goes across different parts of the business. So you might see a farmer business owner who's quite keen on innovations in their livestock operation, but on the cropping side, not as interested, or quite keen on the digital side, but on the physical input side, not as interested. And so, again, the treatment of either AgTech or farming as a homogenous group, I think, is one of the challenges that we face in getting more adoption in the sector.
I might come in. I fully agree with Sarah's comments. I think necessity is the mother of invention, and farmers have needs and pain points, and they differ by industry, by vertical in different parts of the world. What I will say about Australia, versus the rest of the world is we have, a particular set of needs in Australia that is perhaps more advanced than other parts of the world, in the sense that we face climate change more acutely than perhaps some other parts of the world. We have labour shortage issues maybe greater than other parts of the world. And so I think Australian farmers are really hungry for new technologies, but they face other constraints as well. One anecdote I will share is in 2019, I was talking to a potato farmer from the Netherlands. So he was an ambassador for the McDonald's sort of potato program. And he said to me, when he heard I was Australian, he said, I always look to Australia to see what innovations are coming out. And I said, why? We love innovating, but we're maybe not known globally for it in ag specifically. And he said, well, it's because you face these problems ahead of everybody else. You're forced to try things that nobody else is. And so that was really interesting to me, to think that a leading European farmer would look to Australia, even though the Netherlands is so different to Australia. So I think in some respects we are at the forefront of the world.
Jay, you talk to US farmers all the time. You've got a part of your business over there.
Sure.
Are they different customers to Australian farmers?
100 similarities, 100 differences, as they said. But I think there's definitely, in terms of initial adoption, I'd say it's a bit easier in the US because connectivity is more widespread. Financing, 0% for everything is widespread. Try it, money-back guarantee is more widespread. But sticking with it and actually using it and leveraging it, Australians are good at. So I think Australians are more skeptical up front and more careful in their evaluation. And when they buy it, they want to have something that sticks on the farm for a number of years.
Let me move on now I'll come back to finance in a minute. That's obviously a big strand through all of this. The issue of, is this a game for the big corporate farmers? Is it a game for small farmers? How do the little guys get into it and harness the benefits?
Yeah, I'll have a quick swing, hey. It's a good question because I think, so I've had some time inside a corporate farm, and there's no question that there's some ease with which you can at least begin the process and that investigative journey because of available capital, often quite flush with resources, depending on which part of the private equity cycle you're in. And you've got people that can fully dedicate their time to actually navigating that pathway through the business. So working with the respective crop sectors within the business, individuals, what are the pains, marrying them up externally with what solutions are available, building up, R&D profiles and bringing them through the business. I think you're probably in a luxurious position, often in a corporate with that. However, things move slowly in corporates, and the channels and the pathways you go up and down for approvals, and that sometimes siloed way that corporates are set up is ultimately the owner or the user of the tech is often not engaged because they're so far removed from where the original excitement or decision was made. The buyer could be at the executive level and the user is many, many hundreds or thousands of kilometres away and hasn't been engaged. So there's some nuance around that from a pros and cons point of view. I'll maybe let someone else speak to the smaller grower angle.
I would agree from that observation around adoption. We see a lot of investors, from the companies we sit on the board of, they want sort of brand name growers, corporate grower customers, and that's who they want to call. And then they often get feedback like, they haven't fully adopted it and they're just trialing it. And so is this like really good product? Whereas you call some of the true early adopters who are almost always family farms, they might have scale, but it's someone who has deeply understood the problems, who have seen the innovation coming and who are rolling up their sleeves to go, if I get this robot, if I get this sensor, if I get this input, I know fundamentally how it's going to change my business, my team, my succession planning, and they're much greater champion of that innovation. So I think there's a bit of a misnomer around corporates are the ones that are the early adopters. And to give another example, we're running a course right now for aspiring and current AgTech investors to learn more about the space, funded by LaunchVic. And we had a family farmer and a corporate farmer come on to sort of do a session with the prospective investors. And the family farmer gave an overview of the operation and technology. And then the first thing the corporate said was, yeah, Mark, I've been watching you for a while, really impressed with all the stuff you've adopted. Wish we could go that fast. Wish we could have trialed half of that stuff. And I think for a lot of the investors in the room, it was we really expected this to be the other way around, because on paper, the corporate farmer just has such a stronger balance sheet or larger balance sheet, but not really correlating to speed of technology adoption necessarily.
If I could just add one more little piece to that, I think the other interesting thing is a lot of the companies that are approaching corporates or others, small, medium-sized growers, are quite early stage. And the pastoral care that's required to sit and work with those early stage businesses is quite high. And some businesses just don't have capacity to spend that amount of time. Now, there's an opportunity there, right? Because you can influence the trajectory of the business, where they're heading, perhaps help them refine and really keep them grounded on you as the grower or the potential user of the technology where you'd like it to go. But, I've sat with a bunch of businesses recently that say we can't, larger businesses that say we can't do that. We're waiting, and we'll wait till they're more mature, where it's a really clear fit. We plug them in, and then we plug them in as quickly as possible, and we go.
I think, big corporate farmers, they're obviously making decisions based upon the profitability of their decisions, and they need to make efficiency gains every year. I think for smaller farmers, it's hard to talk about technology adoption without thinking about the generational shift that's happening there. So the average age of farmers in Australia in certain verticals is over the age of 60. And we know that older people have trouble adopting new technologies. So they're generalists by nature. If you're a small farmer, you're a business owner, you're a labourer, you're a machine operator, you're a commodity trader, and you're also expected to make informed choices about what technology to adopt. So what we tend to see, I think, with smaller farmers is often when there is a generational shift, the daughter or the son inherits the property, they're willing to try new things because they want to do things differently to the way that the family's already done those things. And I think that's often where you see the catalyst for change in trialling new technologies, whereas for corporate farms, it's more of a sort of evolutionary process that's driven by the profit imperative as opposed to the generational shift on smallholder farms.
Yeah, I think if you go down even to even smaller holder farmers, right? So then there's 10,000 growers in Australia that just family owned, and 80% of the world farmers or smallholder farmers. And I think that to answer a bit more close to your question, Chris, was what we're seeing is democratization of AgTech. So how do you kind of open source some of this technology? How do you kind of open it? But then also the model changes, the business model changes. You move away from selling, and we heard a little bit before about with the chemicals, you move into more of a service-based arrangement. Or cooperative arrangement about certain technology, and that helps adopt that technology through.
One more point, Chris. I think the Australian government did a very good job in the last year with the on-farm connectivity programs. So they subsidised, I think, about 50% of the cost for growers with a turnover below 4 million.
Okay, a related question. Chris Moran this morning talked of the need to integrate the technology. The farmers just can't be dealing with disparate, separate technologies. To what extent is that problem being solved? Are there systems integrators? Are there intermediaries that can help with the implementation of this on the farms, or is it left to the 60-year-old farmers? Anybody?
Bang on, right? I think it's one of the it's one of the big opportunities is to get some better integration. It's super challenging. So if you keep coming back to what we're saying, where you take the leap and you bring a system in, but often they're point source solutions, or they're very bespoke in nature, or they've targeted a single point problem within the business. They might do it very, very well. But when you start stacking those, that's a lot of systems to be across, and a lot of missed opportunity if you can't integrate and really bring that combined data set to life. And again, so let me reference large versus small. When I was sitting in Costa Group, I had a grad who just spent all his days stacking all that data for me and integrating it to work out where was the unrealised potential from doing that. That's a luxury, and that's not how it works for most business enterprises. And I'll let some others speak to perhaps what the chain looks like at the moment in terms of where we're heading. But I don't think the integration is anywhere near as advanced as it should be.
I would agree.
As I was going to suggest, is it something for the industry, like for the industry body though, to dictate? Because I've worked in mining, I've worked in aerospace, I've worked whatever, and everyone has the same questions about how do you stack software, hardware, whatever it might be, in whatever form. And if it wasn't for the industry body itself dictating, because the gatekeepers at the moment are the same people that are selling the products, right? They're saying this is the standards to follow, and whatever it might be. And I'm just wondering whether Hort sits down and goes, let's sit down with MLA, whatever it might be, and this is kind of the standards that we want to follow, so that everyone, and to plug and play. I know it doesn't make, it doesn't make sense in a capitalist society, but I haven't seen it work any other way, unless you get these big industries dictate it.
It's a great question, and I'm loath to talk about Hort Innovation dictating anything. But I think my mind always goes to surely the market will play out, and integration and some consolidation by default will have to happen, and then we'll see things come together. There'll be pairings and partners. It's a good question, and I don't have a clear answer for you.
National Farmers Federation, I think, has started a pretty good set of standards and guidelines. It's far from complete, but I think they've started to put in good checklists for buyers of new AgTech to check these things before buying.
Well, it's a takeout, I think, for the work going forward. We'll have a summary session end of the day today, and I'm sure there'll be a number of points that come out for future action. Let me now move to the sort of gloomy subject of finance. Some of you provide finance to farmers. At least one of you, Jay, you're a finance taker. How is the industry? How's it going? What are the obstacles? What are the challenges? Are we doing well in Australia in terms of that dimension compared to comparable countries? Anyone who wants to lead? Sarah.
So when I'm American, you guys can probably tell by the accent. When I came to Australia just over 9 years ago now, I Googled AgTech and nothing came up. I had to find digital agriculture, and there was some early work from AFI and the RDCs doing work on precision to decision. And definitely in those first couple of years of being here, I got asked questions. Oh, you're from Silicon Valley. You've worked in tech and commercialization. It's time to raise an AgTech fund. We need an AgTech fund for Australia. And I was like, no way. Like, that just does not make any sense. And had to then eat my socks in a couple of years later, deciding to raise an AgTech fund for Australia. And now there's several folks in different models playing in this space. So I think just to zoom out, if we're really looking at last year and this year of current economic conditions, things look pretty challenging, and you can find plenty of LinkedIn threads sort of bashing VC and bashing capital in this space and bashing AgTech. But if you zoom out, we haven't had financial models or capital models to fund high-risk innovation in a really important sector in this country. And I think it's really important that we have that and that it's appropriately risk-adjusted, appropriately contextualized, and part of a system of tools in the toolkit. By no means do we believe that venture capital is the only tool for funding innovation. So I think that would be my first statement, just the context of why it's needed, that it hasn't existed, and that now it really does. To the point about current conditions and challenges, it is tough out there. I think the venture funding world is really grappling with how do we fund things that aren't software? How do we fund things in current conditions when it seems like you could put $1 into an AI company and turn that into $15 in about 10 minutes? Why would I literally fund anything else? Whether that's true or not, and how long that lasts. But it's a real question on people who are allocating capital's minds right now. And then, there's seasonality and, 60-year-old farmers. And so is this a sector that I'm interested in? And so I would say there's a set of headwinds for sure. There's also a set of really strong tailwinds around food security, around national sovereignty, around the fundamental shifts in what it's like to farm in a climate changing world, in a macroeconomic trade volatility context, in autonomy coming in and eating the margin of chem companies and shaking things up. Like there's plenty of tailwinds as well. And so I think for the right kinds of capital models and the right kinds of theses, there's really happy and impact and return aligned times ahead. But for sure, if you're a company, whether a fund or a startup raising money right now, it's pretty tough to be looking for capital.
Jay.
Yeah,
Right.
I would agree with what she's saying. It's all timing. So, there's times to take it, and there's times to break even and live within your own means and maximise the Australian government R&D tax return and maximise what's available without VC for periods, and then revisit with VC during the better times. I think most ag companies and most ag tech companies are used to the long, slow cycle of ag, and a drought will come every 5 to 7 years, and we have to get through it. So it's very difficult to compete with a unlimited scale software company. It's very difficult to compete when you have the physical weather on-farm devices that break down and you have to drive 300 miles to visit, and then VCs don't like that. So it's got a lot of costs and headaches compared to, I'd say, pure software industries that are more attractive. But if they have a bigger agenda related to sustainability, climate, food, or some other investments, what we're seeing in other ag tech companies where this becomes a useful part of their portfolio, then we're more likely to get it.
Sarah, Jesse, why does it need to be scaled? Why do we have to think of AgTech purely as from a VC perspective and say you go from it needs to kind of solve 1,000? Why can't it just be a business, for example? It does it because that was one of the things that I got asked a few years ago, which was just, can you can run your own, you can do a business, start up a business, run a business, and kind of do it, and that's it. You start solving the problem. Is there an alternative, or is there another way of being able to kind of take on that activity, or does it need to be something where we're sitting down going, we need to compare it to an AI model? And when it comes to hardware, it's a hard, it's the flywheel to kind of get to a point where there's something robust and working. Takes many years.
Yeah, I mean, I hate panels that all agree, so I'll try to not agree while I agree. It depends on what door you come through. So if you come through the world of capital allocation, and as someone who now manages money, takes that extremely seriously, but didn't come from this world, didn't speak fluent finance, had to learn a lot of this through genuine scar tissue. The capital allocation world thinks about things in buckets. And so the bucket that gets the high risk money is called alternatives. You've got sort of private equity, you've got venture capital. The venture capital bucket is high risk, high return. And so anything that gets allocated to a fund that then goes to other funds or to startups is looking for a particular risk return profile. And that kind of sets up the whole system. And so if you're a startup coming to a VC, you're fitting your puzzle piece into their capital allocation model, and they want things that look purple. And if you've got something that looks pink, you're probably not a fit. And so that's kind of the landscape of the system now. So if you're someone in that purple bucket going, well, why would I fund the pink things when I could fund the purple things? Like, that's the answer, is there's other places they could put their money. Now, if you come from a different angle and say, I believe in the fundamentals of agriculture, the impact potential, the importance to Australia, well, then how do I make money in this space? And if you're a startup, then who is the right capital partner for my business plan? And I think right now there's been for sure too much focus on venture capital because it's really been the only one, to my point before about the context in the system, that's been the only place to go. And so now what's exciting is there's more types of options coming into the system. There's venture studios that don't take equity, but that provide support. There's university commercialization incubators. There's RDCs looking to match funding and partner. And so we are starting to move away from just the one type of tool in the toolkit. I mean, even just to speak for us at Tenacious, we have a capital side of the business and a insight side of the business, and capital has never been envisioned to just be venture capital for exactly this reason, because we see good businesses that are making money or that we think will make money, but they're not going to fit the purple 10x bucket. That doesn't mean they're not a good business. We just have to take on the challenge of finding someone who doesn't see the world through purple and figuring out how to unlock those funds.
Just on that, is how many, so, you know, the kind of portfolio 1 in 10, whatever, but how many really in AgTech fit in the purple and are successful?
Well, I mean, that goes to the sort of existential question of in the space right now. So if you look at what kind of kicked off venture investment in AgTech, this would be sort of 2012. Monsanto acquires the Climate Corporation, about $1 billion. A couple years later, Deere acquires Bear Flag and Blue River, a couple $100 million each. There's been some biologicals exits. And so a bunch of folks said, well, this is the next space that's going to unlock this kind of funding. This must be the early data points on what is a trend. Let's raise capital, and it's going to fit this kind of venture model. Now, I think a lot of those people have been and will be disappointed, because if they thought it looked like software and behaved like software, they weren't really looking at the fundamentals of agriculture. Now, I get the irony of saying that with someone who manages venture and is raising venture. We believe it's one tool in the toolkit, and that there is a way to apply high risk, high reward capital, even to capital intensive businesses, even in agriculture, to make money and deliver impact. But it does not look like the same flavor of doing it in software. And so, you know, whether we're right or wrong, whether, you know, those are time will have to tell. But I think we've seen a track record of companies thinking that, well, if you just give a vertical farm more money, they'll someday pay it back. And I think a lot of people are pretty unhappy with that hypothesis.
Yeah, I would, again, echo everything that Sarah said. I think it's undeniable that the deal count and the value of those deals has declined since about 21, 22. Globally, it's down about sort of 24%, et cetera. We're in that long cycle where investors are realising that with interest rates rising, et cetera, that AgTech is not clean tech or med tech or fintech with those outsized returns. It takes a lot more than money just to succeed. You also need those industry connections. You need to be able to advise companies, et cetera. And I think that's that harsh reality I think Sarah's talking about, that investors are learning that AgTech is a much more complicated space. But it's not a uniform picture across AgTech. Obviously, we were talking before about indoor farming and vertical farming, raised a lot of money, and there have been a lot of high-profile bankruptcies, so a lot of people have been burnt on that. Similarly, there are a lot of alternative protein companies sort of, you know, growing steaks in labs, trying to create synthetic protein. That hasn't done so well recently as well. And that's sort of those really high profile failures really damage the industry in the same way that those really high profile exits in 2012 and the mid 2010s really helped the industry. So I think once we get some more big exits, I think the money will start to flow back into the sector. But we still do see money flowing to good parts of the industry and maybe later stage deals. So biologicals is still a hot sector because there is a natural path for them to exit and to plug into the existing business model of selling biologicals to farmers. If you are a successful company that's demonstrated real traction, you are able to raise money predominantly overseas. It's a bit harder in Australia to do that. But I think as those companies do well, it'll attract more early stage funding back into the sector as well.
Are the big four banks active in the space? Jay, I know you've got Westpac as a shareholder, but are they playing a role they potentially could play?
My analogy would be somewhat similar to the corporate farms, but a bit worse in that they're really happy to pilot. They love a good pilot. The banks, real adoption. bit trickier to get there. And I get it. Risk, systems, IT infrastructure, it's not a criticism. It is the stage of their innovation cycle that they're at. Keen, excited, love a good pilot, love a good consultant. Moving past that has been a bit tougher thus far. What we've seen overseas, and that's a good comparison, I was on the phone with 3 fund managers this week, just talking about different things, and all 3 of them, interestingly, one from Canada, 2 from the US, all of them have banks as limited partners in their funds. And so that's an area where Australia has struggled, where the corporate, and whether that's agribusiness or finance sector adjacent to ag, have been much more hesitant to say, let's back the backers in this space than in other geographies. I get the self-serving nature of saying that up here as a fund manager. We just frankly haven't even tried to knock on those doors because that's how hard it is. So it's not I'm complaining because they're not doing it. It's like, it just hasn't been worth our time to give a kind of sense of the maturity. We have overseas corporate investors. We have more private equipment dealers, kind of private agribusinesses, but from that kind of bigger end of town, we haven't seen it as particularly good use of time.
Okay, thanks for that. Good discussion. Let's move on to sustainability, environmental issues. As Sue pointed out this morning, that's kind of a understated factor. Probably should be given more prominence. In the automation space, is that emerging now as a major driver of innovation? Salah, you referred to it partly in your presentation. What do you think of it from a panel point of view?
Is it a major driver? I think it's increasingly becoming a major driver. I think the fundamentals of faster, cheaper, quicker, with less people, whatever, are still pushing hard through the horticultural sector. But no question, and again, it depends which end of town you're at as to what maybe how much sustainability is driving you. Are you in a high reporting function part of the sector where you live and die by ESG reporting, or perhaps the requests of the duopoly? You're very interested in being able to back up what you're doing around solution adoption and so forth. But I think if you look at most of the solutions somewhere around them, they've taken a sustainability angle. Even the IoT stuff you referred to, Salah, early doors, a lot of that was around optimisation of water or input, be it FERT, be it CAM, and doing it with within a precise nature, and therefore being more sustainable in the way we're applying those limited resources. So I think it's always there, but no question, even if you took the pathway of having some belief in a chemically limited future, there's a lot of movement and trend and money that will head towards solutions that are starting to address that, purely from the fact that it's a much more sustainable and what will be an absolutely needed approach.
I would say the shift we've seen in sort of the correlated with, but we'll see if related to, the kind of hotter capital markets in 2020, 21, 22, a lot of focus on sustainability, and in ag, a real shift from, pitch decks not talking about this to carbon and ecosystem services and sustainability and all of that really front and center. The difference, I think, between that and what's always been true in agriculture is some of the businesses we've seen more recently, sustainability was the monetization mechanism or the driver. So we will make money through carbon credits. We will make money through insetting. We will make money because of sustainability regulations. Whereas I think it's always been true in agriculture that in many cases, profitability, resilience are aligned with what you could otherwise call sustainability. And so I think there's a question of business model sort of primacy. Are you solving for a productivity or resilience driver and you're getting sustainability co-benefits, or vice versa? And I think the recent times saw a lot of sustainability front and center, whereas I think there will be a shift back to sustainability as a side dish or nice to have. And you can have views about what you like more or less, but I would say that's the kind of trend we're seeing. Our view at Tenacious is it's both. And so you can put, we from a scale perspective, unlocking impact at scale, we need commercial solutions. Otherwise, you don't get impact. We also need impact aligned to those commercial solutions. But for us, the commerciality has to pull that impact to scale and realization.
Yeah, so it's a quick thing. So absolutely bang on that last point, which I was going to make myself around. It can't just be sustainability for the sake of, if the commercials aren't around it, the businesses just won't take it up. But one thing I have noticed in the last few years is growers don't like it being inferred or being told that they're not sustainable. right? They believe they've been good custodians for many, many decades. And when someone comes in where their value proposition is, we're going to make you more sustainable, or we're going to make you sustainable, it doesn't fly. And there's pretty fair reasons why it shouldn't.
And I think to kind of close on those two things, the technology is both so automation, whether it's IoT or robotics or digital analytics or whatever it might be, is both to help with the precision, whatever that might be, reduction, but also help with the monitoring, so help with the data collection and then using that as a predictability tool to kind of bring about sustainability, whatever that might be.
Okay, let's move to labour workforce aspects of it. I mean, clearly, where you see automation, you tend to see labour productivity, and I want to explore to what extent this is a major driver. Are we seeing new skills required that aren't currently there? Are we seeing workforce displacement, which you sometimes get with disruptive technologies? So again, let's go around the panel with that issue. Why don't we start with Marcus?
It's a really tough question to answer. I think we're so early on the robotics journey that we haven't seen displacement yet, but I don't think, I wouldn't say that we won't see that over time. At this stage, I think, robotics and automation is supplementing the workforce, making farms more efficient, and could actually be creating jobs, different sorts of jobs perhaps. But during the pandemic, a lot of the world realised that they have a problem moving around agricultural and seasonal labour around the world, and Australia is no exception to that. We rely upon large seasonal workforces from Polynesia and so on to provide a lot of the hard labour that Australians are unwilling or unable to do. That's a challenge to line up that labour months in advance to get the visas for those people, to have the labour on farm when you need it, to pick in a very narrow cycle or to harvest in a very narrow time. So there's just key advantages to having automation, to giving greater flexibility and moving away from the long lead times of trying to get seasonal labour and so on. So could that seasonal labour be increasingly displaced as robotics get cheaper and more efficient? Probably. Will it create higher value jobs for people who play the data scientist role, the machinery repair person, the integrator on farm? Probably, and that might actually create more jobs in rural parts of Australia for Australian workers. So I think it's really hard to say in the long run, but I think it has opportunities as well as potential long-term costs.
Yeah, I might just add a little bit there. I think so. Pull the Band-Aid off, no question it will displace at some point, right? So, and you're seeing it already. So if you look at, where's a classic, perhaps post-harvest, so in pack houses, fruit production. I can think in my mind of a direct example now of where automation and vision systems displaced probably 80 fruit sorters and left them with 18. It's a straight up displacement of people that otherwise had a job doing a mundane sorting task, right? It doesn't matter how mundane it is, they were getting paid to do it. And they were happy to do it. They've been displaced. Outside, it's going to be slower and harder. So the very heterogeneous nature of horticulture and also just the variability that exists in farming systems means that the pathway towards things like robotic harvest, which would displace a lot of pickers, is slow, and it's still the promise that everyone's waiting for. Although I sat with Driscoll's recently and I was amazed to see them commit to paper that it's way back down their list of priorities now. Like it's gone from what always sat at the top to there's almost a belief that maybe it's a long way away, so let's focus on some of the more, pardon the pun, the low-hanging fruit, the things that we can grab sooner and move on quicker. It doesn't mean it's not a priority. The other quick consideration is, automation, I believe, still needs supervision. Now, Salah will tell me soon enough it won't. But, I think of chatting with Costa Group the other day. They talked about, autonomous tractors and sprayers coming in and doing a range of work up in Queensland, and instantly you're like, oh, cool, like what was the headcount saved? And they're like, oh, no, I haven't saved any headcount, but the job gets done on time, gets done. The See and Spray is turning on and off, it's managing variability. We get a full track record of everything that happened. We're not missing rows. Our incidence of disease or mite pressure's gone down, and so you see these flow-on benefits, but it wasn't about, oh, great, we shifted 3 tractor drivers, because they're actually now running around in chaser carts filling up the, the Gus sprayers or whatever that are running up and down. Someone's still got to attend to them, yeah.
I think the thing we're missing out on automation is using automation to assist human workers. So we've gone from, there's human workers, and we're going straight out to autonomous farms, and we're missing this big spectrum in between, which is, how do you kind of gradually introduce it and improve productivity? You still have workers on board, etc. And I think there are many opportunities in that to kind of even commercialise that type of tech going through. And I think the other thing that, from my experience, is that you can bring in the tech and it kind of works and whatever it might be, even if you got it working at some point. But the operational readiness of a farm is not there either. So it's how do you kind of get the farm into an operational mode, and that requires a certain level of education, both in the community as well as what happens on farm. And I don't think we've got that down as well.
Absolutely think the space for our thesis on autonomy is there's things that machines do and things that people do, and autonomy is an interesting blend of both things that people do today and things that machines do today, and things that neither can really do today because we don't have autonomy. And so it's opening up a whole new market. At first, for sure, it will be humans and machines working together. Even with something like Swarm Farm, autonomous agricultural vehicle company, one of our investees, I sit on the board. They've got customers who've talked about, I drove the header for 18 hours. That's a normal day. But at the same time, I had 2 swarm bots also doing 18-hour days, spraying. And so we did a week of work in a day because I had autonomy, and that just wasn't possible beforehand. Now, whether you think that those robots were replacing the people that would have driven the sprayer, whether that job just couldn't have gotten done because no one does that job and there wasn't any labor to do it, I think the point is that it's the combination of the humans and machines and how they work together. To the point before, you're also going to see we don't have full autonomy, like autonomous operations yet, and a lot of the tech companies have delivered sort of partial autonomy that needs a lot of humans. And I don't think there's been enough focus on the user experience. Like, why not sort of give as if you have full autonomy and do a lot of the task management and humans and coordination behind the scenes. Our first investment in our second fund is much more in that space. And so we see that, like, how do humans work with machines in a future of autonomy is absolutely kind of blank space, territory, because we just don't know. And there's plenty of roles for government and industry around operational confidence in the autonomy space, insurance, liability, like big industry challenges that we haven't fully taken on that will be really important to give growers confidence to explore these new technologies.
Can I? Yep. Just super quick.
Sure, Jesse.
Something really interesting that's in line with this conversation that I saw the other day. I'm not sure if it did excite me. It was pretty cool, but so no less people, go with me for a moment. So no less people harvesting, but the people that are in control of the harvest are sitting in another country and they're wearing a headset, VR, whatever, and they're operating, they can see the crop. And then on the other end, you've got robots that look like humans with discretion and hands harvesting the crop, but the people in the other country are guiding the motion to do it, right? So, okay, real moonshot stuff. It's way out there, and anyone can prove a concept. And let's not even talk about whether it will come to fruition. But think for a minute, there's still the same amount of people because it's like one person still harvesting against one vine, but it's thinking about that school of thought is, where do I get a low cost individual to do the task and use technology to be the enabler to allow it to happen somewhere else, and that's quite mind-bending when you think about it.
Yeah, but I would from an R&D and then it's easier then to just fully automate than it is to worry about the communication issues, the delay issues.
Right, so there's a latency thing that they're coming across and so forth, but it's another way of thinking how some people, for sake of discussion, are thinking, no, we don't need less people to do it, we're just going to change the way where people sit and how they do it.
I think just going on what Sarah's saying, because some of the things you see is like drones flying over crops, determining which rows are ready to harvest, sending the workers there. So you're not having people just kind of trawling up and down. So that's where that kind of blend of automation as well.
One example of a really simple automation company that is dealing with this challenge is Burrow, which is a robotics company in the US that just basically it's like a robotic donkey. So you want to move something around a farm, it just takes it from where the workers are back to the shed or something like that. Really simple. It just alleviates the fact that somebody doesn't need to drive backwards and forwards all day. So they just raised $24 million over the last few months in the US, and I think that's the sort of example of really simple automation that can actually be a game changer for farm efficiency. And I think we'll see more of that simple automation on the journey to the full automation that the others are talking about.
Okay, we'll move to questions in a minute. Just a 60-second response, if I can. I need to cover this topic. The policy settings, government regulatory policy settings, that whole issue of infrastructure policy settings, very quickly. Who wants to start?
Not me.
Well, this is a chance to actually crystallise some sort of message. Future work plan.
I'll go with a specific example. I think we've spent a lot of, so Australia's a really good place for innovation, R&D tax incentive. Like I genuinely wouldn't, I'm from Silicon Valley, I could go back there. I wouldn't be here if I didn't think the ag industry and the innovation space was worth being in and spending time in. I think specific opportunities in agriculture will take having a go around a particular issue. And so if we take autonomy, because we were just talking about it, we've floated the idea of why not have Australia or a state in Australia or Australia and New Zealand be a regulatory sandbox for autonomous operations in agriculture, and let's have a crack at work with the insurance companies, figure out, get data on the actual liability, the actual risk, quantify it, build the insuring models. Let's make every autonomy company in the world go, I'm going to Australia and New Zealand because we've solved this operational regulatory clarity around moving robots between fields and worker safety and all this kind of stuff. And that would be a boon for agriculture here and for the tech companies and for innovation. And it wouldn't have to be, let's go change regulations. It would have to be, let's create the conditions for the data and certainty and private sector incentives to evolve such that then we know what conditions we want to create. But that's pretty different than how we tend to operate. That's not a grant, unfortunately.
Yeah, no major builds. It's an opportunity to lead for sure, and I'm always mindful that we don't, particularly on the autonomy side, we don't regulate ourselves out of the opportunity to begin with. So,
okay, thanks. Look, Q&A. Question here from George Maldonborough. Is there much interest in measuring soil carbon to facilitate soil carbon sequestration? Actually measuring, doing the metrics on soil carbon.
I'm happy to take a crack. Yes, I would say for sure we see plenty of technologies with capabilities to do that. The challenge has been probably more of what we talked about. What's the business model for those technologies? What's the driver? I think there's really good evidence that increased soil health will improve productivity, resilience, yield, et cetera. But measuring it at what kind of depth, with what kind of time, with then what kind of use of the data for what kind of benefit is where the kind of business model piece falls down. The places where we've seen that has been probably more in the Australian carbon credit unit, regulated scheme, and there have been examples of folks monetizing through that pathway. But I would say at least from a kind of tech investment perspective, the business models in my mind are still up for questioning.
Salah?
No, there's not.
Okay, moving on. Elena Denavi, how much are farmers involved and interested in AI technologies? Are they interested in investing in the outputs of the research done in this field? I think we kind of covered a lot of that.
Can I give one fun example because I love it? We did a podcast last year. This was maybe even 2 years ago, pre everyone using ChatGPT, and had a farmer talking about his early use of ChatGPT, and I expected it to be, he chucked some agronomic data in or whatever, and the conversation he had was I want to buy my neighbor's farm. How might that negotiation go? And it was much more like wargaming what's he going to say? And okay, what if his wife's in the room? And then what if my wife's in the room? And then, okay, but they have 3 kids and I have 4. And literally that was the conversation that they went through. And he's like, it was so useful because how else do I prepare for that negotiation? And so I think the ways we're thinking about AI on farm pretty quickly goes to agronomy and autonomy. And I would challenge us or invite us to sort of expand the thinking, farmers are humans, they're running businesses, there might be some different use cases.
Anonymous question here, which refers to Salah's 5.0. What additional training will be required for Australian farmers and chain operators to take full advantage of 5.0? So I guess it's how do we get in terms of universities, TAFEs, on-the-ground education to tailor us towards that? When will the farmers be happy to interrogate LLMs with natural language?
Yeah. No, I think it's a while to go. And I think we've touched on it before. I mean, how we use AI is one thing. This is all new aspects of the university, and R&D labs at the moment now, and then proving it. I'm sure even with the negotiation case, it's nice in those scenarios because all you're doing is you're expanding on the textual frame and giving you a bunch of different options that you as a human can then look at. When it looks at acquiring and looking at data specifically and pulling out results, when the accuracy there is not there, repeatable accuracy is not there. So whether it's at 80% or 90%, but I guess the farmer doesn't want to come along and trust in certain actions without getting that 100% confidence. So I think we're still a while away.
Michael Aldridge, should we and how can we encourage more ground-up development like Goanna? Would that help adoption if farmers are more involved from the start? In other words, are these startups going to come from the farmers, or are they going to come from PhDs and universities, or a mixture of both?
Yeah, I love it. That's an awesome question, and I think absolutely. So as soon as possible, you should be in front of your customer, right, or who you think is going to be your customer, and looking and listening and asking 1,000 questions. And gosh, the amount of early stage businesses that I've sat with over the years that haven't done that and can't tell me what the problem they're solving and why they've embarked on the journey. And it's the classic tech first problem set, all that sort of stuff. So I think that sooner and earlier you can get in, and we know certainly within Hort Innovation, it's one of the things we're hyper focused on is to be able to support these businesses to get in really early with the likely customer.
Do you think there's a bit of danger in pitting and I don't think you were doing this, Chris, but pitting the like tech versus ag, like if we could solve all of these problems with one or the other, we probably would have. The interesting thing now is that there are new incentives for those groups to work together. And so how we work together to me is a much more interesting question, and conditions for innovation policy settings, for R&D type funding to drive incentives for let's get the best and brightest of both worlds working together would be, my invitation for how to think about that.
I think there's an efficiency question, like, so, dollar for innovation kind of thing, so talking to the farmers directly and straight away to kind of, okay, this is their problems, and okay, now what do I have to do from the R&D all the way through the translation and commercial adoption? And then there's also how do you just fund blue sky activity where it's just like, what does farm look like in 10 years' time, or what do we think it should look like, and so how do you fund? So I think there's that technology pull and push aspect that we need to look at.
Question from Mark Bryan, who I know is a beef cattle farmer. Question for Salah: are there AI products and models that use computer vision to assess cattle condition and weight to inform optimal time for sale?
Okay, I don't know about the optimal time for sale, but yes, there's lots of OptiWay was one that we saw earlier today, which was the ability to kind of condition score an animal as it's going through and foraging. There's guys at the University of Sydney that are also working on systems like that. We've done work in the past in crushers where animals go through and using vision and IR to kind of measure the body condition of animals. So there's a lot of aspects of that. And we heard before from Sue that now there's this aspect of in the abattoir, post-analysing fat to meat content, what does that mean about what happens on the farm as well? So there's vision analysis pre and post gate and what happens there. As to optimal selling, I don't know about that one yet.
Salah, there's a bunch of questions coming through for you, so you should give you the microphone back. This one's anonymous for Salah. Obviously, Ag 5.0 could assess whole mixed farm profit risk profiles, key for farmers. Why do none of your models show these types of results? That's a
Yet.
I was given 15 minutes, I think. So 5. Okay, we've got 5 more minutes now. No, but we just have that space. It's all new at the moment now. It's all very early, and the focus has been around aspects around ESG or SDGs and how do you kind of measure that on farm and couple that in within operations. But you can see that the concepts will kind of bring them out all the way through into the commercial supply chain realities as well.
Okay, hang on the microphone. From Sabina Schmerzel. Salah, could you comment on the opportunities and how we get information on the needs of livestock from the animals themselves through various sensing methods?
Yeah, I mean, there's a lot of work on e-tags. I've seen some work about necklaces that the animals wear, which look at measuring acceleration and head movement and how much they munch and so forth. There's many aspects like that. We also saw from Uruguay, I think it was, measuring the kind of methane aspect. So I think there's lots of different activity there in the measurement process. It's much harder, even with Swagbot, the robot that we had there. I said before that we kind of leave it for a few days and the animals get used to it, which is great. But then it becomes a scratching post, and so you've got this 500 kilogram beast against this 100 kilogram bot, and part of it's monitoring, part of it's running away. So many things you got to look at.
There's a few fun examples of that. More broadly across ag, there was a company out of India that we did some advisory work with that had detection of, it listened for shrimp in shrimp ponds for the chewing, and rather than trying to direct monitor feed and water, and it was all complicated, just could you hear them chewing? And if they weren't chewing anymore, they were probably hungry again. And so I think interesting sort of approaches like that. We have a company in our portfolio that uses knowledge of insect of entomology, of the body composition and behavior of insects to detect what type of insect, is it a beneficial or not, and then make recommendations. So I think the world of nature-informed technology is something we'll continue to see more of, because why go against what, the knowledge that's already there.
Okay, next, we've got 3 more questions, 3 more minutes. So quick fire answers. This one's anonymous. Do most farmers trust AgTech? They understand how tractors work. Do they view sensors and data analysis as magic?
No, I don't think they do trust AgTech. I think they want to see results first. But even with tractors, there's obviously a lot of mistrust to the big tractor companies because of the right to repair and so on. So I think farmers are suspicious. They want to know that their privacy and their data is protected because they worry that it can get used against them. So I think the short answer is no.
I'd agree. I mean, they can be converted for sure, but takes a bit of time.
From Bob, will the technology and skills required for this farm transformation continue the push towards bigger farm units, consolidation or cooperatives? Well, I think we kind of touched on that. So we'll probably take that one as already answered. Last question, anonymous. What disruptions do you anticipate for automation in farming due to the reduction of free satellite data from the US? Interesting one.
I had this conversation with a farmer recently who was saying how I asked about challenges, and it was in this investor course, and they were saying, well, if you had asked me, a year ago, it absolutely would have been connectivity. Like some of these things were just a non-starter. Now I've got Starlink, but I'm now genuinely worried about the risk of one human's psychology for the ability to operate multiple critical functions across my farm. And so I think that's a real question from a risk perspective that is playing out in many industries right now.
Yeah. Bang on.
Okay, so let's wrap it up there. Thanks to all the panel. We've had all the questions. We've had all the topic right through a number of different aspects of it. Thanks, Sarah, Jesse, Jay, Marcus, and Salah, and thanks to the audience for the questions. Thank you.